Here we go. One more going into it. Actually, we got three more, counting this one. But just one more going. Anyway, brain going a million miles an hour. Million miles an hour? I hope that's what I said. Anyway, here we go. We got two things to answer. We've got a hockey rink. There is a trapezoidal shape behind the goal. Now, I haven't looked at a hockey rink in years, so I don't know if this actually is back there or not. Never played it, so it's not something I'm 100% familiar with, but it's definitely a good question. What they want to know is, what is a formula we could use knowing it's a trapezoid? Could we simplify it if we know a couple of measurements, but we aren't quite sure exactly what it is? In other words, if we have a trapezoid, and I'll draw it up top, a trapezoid is a shape where you have two parallel lines that are bisected by two non-parallel lines. So here we have a parallel line at the top, we have a parallel line at the bottom, we have non-parallel lines on the side, so this is a trapezoid, yay! And just like any other court or field or whatever arena, one side is a mirror image of the other. So down here was another trapezoid, and this is the one they decided to zoom in on. Well, they are saying that where the goalie stands is X feet long. We don't know that much, but what we do know is from side to side, that same measurement is extended by 10 more feet on its parallel line. And we are told that right here. We are told that the goalie sitting right here, X feet wide. We're told the parallel line is X plus 10, so 10 feet more than where the goalie stands. And we're also told the height, or the distance between the goal and the backboard, is X minus 7 feet. We just don't know how wide that is. For some reason, we know it takes 7 feet off, and it's goal to backboard. And if you add 10 feet, that's the length of its parallel side to where the goalie is. All right, with all of that mentioned 100 times now, what we get is our base 1 is actually what I have highlighted in orange. Technically it's orange or blue, but I always go with whatever I read first, top to bottom. Now our second base, therefore, is the line that's parallel to it, and our height is the distance apart they are. So if I go in and I look at my first base, that is X. If I look at my second base, that is X plus 10. And if I look at my height, that is X minus 7. All right, now that we have everything substituted in, it's time to look at trying to simplify this. Well, I can combine my two x's. There's no actually addition or subtraction, multiplication, division, or anything I can do inside the parentheses in our numerator. So I can actually combine my x's to be 2x, because those are my like terms. There's no like term for that 10, so I'm just going to keep it. And for some reason, I erased that 2 and didn't realize it. Now, I haven't done anything over here with my height, so it's going to stay. Now, there's a rule that says if we're adding numerators with one denominator, that's the same thing as adding two separate fractions where the denominators are the same. So I can actually split those apart. The reason I'm going to do this is just to remind myself I can simplify this. Now, you don't have to do this step if you already know you can. This step right here is only showing that if we separate it apart, we're able to simplify it. So that means whether we separate it apart or not, we can still simplify it. So we do that by these 2's canceling and leaving me with X. 10 divided by 2 is a positive 5 because they're both positive. And then I have my original of X minus 7. I'm not done. I can actually solve this now. So I could use FOIL, I could do everything else. I'm going to do FOIL or a method thereof just because that's what I'm used to. I get X squared minus 7x plus 5, so that's a minus 2x and then I get a negative 35. So here's my answer for part A, or the polynomial that represents the area of the trapezoidal region. Now, if we're going to find the area, the actual area, let's say we finally find out 18, and we find out 18 is our base. That means everywhere there was an x, I'm going to put the number 18, and then I'm going to solve. So this becomes 18 squared. So I take out my calculator and I do 18 squared. I get 324. Then I'm going to add 2 times 18. Well, 2 times 18 is 36. And I'm going to subtract off 35. 36 minus 35 is 1. Add that to 324, and I get the answer of 325. So what I find is the area of the trapezoid behind the goalie is 325 square feet.